In this video, we will work out problems from exercise 1.3. But before we go into that, let's try and understand a few concepts. First, what we need to know, what is a function? F of x is equal to 5x plus 3 is called a function. So let's try and understand what a real function is. A function can be defined. Let A and B be two sets. A relation f from A to B, a subset of the Cartesian product A cross B, is called a function from A to B if it satisfies the following. Condition number 1, for all A that belongs to capital A, which is a set A, there is an element B which belongs to the set B such that A comma B belongs to F. And the second condition is that if A comma B belongs to F, then A comma C belongs to F, then B is equal to C. What does this mean? Second condition mean is, if you have A comma B belonging to F and you have A comma C belonging to F, then the B and C have to be the same. So this is the main condition of a function, and that will be the difference between a relation and a function. Like, consider over here, let this be our function. Okay, so you input a number into this and then it gives you an output. So let me define my input, let's say my input is x. So when you input an x into a function, it comes out as a y. So if you consider y is equal to 2x plus 3 as a function, so let's say this is a function which is y is equal to 2x plus 3, for example. So when you put in, let's say this is your x and this is your y. When you put in 1, then if x is equal to 1, then your y is equal to 2 times 1 plus 3, which will be equal to 6. So your y will be 6. And if you put x as 2, then when x is equal to 2, your y will be equal to 2 times 2 plus 3, that is 7. Your y will be 7. So I can draw 1 is related to 6. 2 is related to 7. Similarly, 3, if I put say 3 here, then y will be equal to 2 times 3 plus 3, that is 6 plus 3 is 9. That's a 9. So that's a function. So in a function, the condition is 3 cannot be related to two numbers in y. So this is called a domain. X is your domain, and that's the input, and y is your range, that's your output. So whatever you put in the input, x, should give you only one value of y. It cannot give you two values. So x should give you only one value of y. So that's the most important condition of a function. So here what we have said is, if a comma b is a Cartesian product, okay, of the sets a and b, and a belongs to, small a belongs to capital A, small b belongs to capital B, then the relation a to b, for it to be a function, is a should be related only to b. There cannot be another relation c. If that exists, that b should be equal to c. So that's the condition of a function. So codomain is all the sets of all the output that we can get of for y, or the values of y that we can have, and range is a subset of codomain, or range exists inside. If this is codomain, then range exists inside of codomain. Now let's look at what are equal functions. Equal functions are two functions f and g are said to be equal functions if their domain are same and f of a is equal to g of a for all a in the domain. There are many ways of representing a function. So first is the tabular representation, where you can have the values of x and y in a table, x1, x2, x3 and so on, and the related value of y, which is y1, y2, y3. So this is one representation. The second can be a graphical representation, where the domain is taken for the x-axis and the range is taken for the y-axis, and you're able to plot a curve or whatever is your output. So that's graphical representation. Then analytical representation is when you represent it in terms of f of x is equal to a function with an interval. So such representation is called analytical representation. Now the vertical line test is a very important test to find out if it's a function or not. Now let's take this first example. Now this is your domain and this is your range. Now 1 in your domain has two values in range. So if you draw a vertical line like this, the vertical line will touch this curve or this function in two places. So when it touches in two places, that means it's not a function. Similarly here, if you draw lines, they won't touch in any place. So this is a function. So this is just the illustration to show that the first one is not a function, whereas the second one is a function. Let's define some functions. So if x be any non-empty set, then the function f x to x defined by f of x is equal to x for all x belongs to x is called an identity function on x. It is denoted by ix or I. What does this mean? That every element is related to itself. Then A is related to A, B is related to B, C is related to C. So every element is related to itself, so it's called an identity function. Second is a constant function. So I'll just quickly explain to you, if all the values of A have the same value in the range, which is like A has Y, B has Y, and C has Y. For any input value you give in X, your answer is a constant. So such functions are called constant functions. And a zero function is f of x is equal to 0 for all x. Then modulus function or absolute value function is a function which is always positive. So when we say mod of x, it is minus x when x is less than 0 and x if x is greater than 0. So this is represented as mod x, but then f of x, which is mod x, will always be a positive number, will never be a negative number. So that is called a modulus function or an absolute value function. Then let's define a few more functions, which is signum function, which is f of x is equal to x by mod of x if x is not equal to 0 and 0 if x is equal to 0. This is called a signum function. Next, let's see what is a greatest integer function or a floor function. So this is the greatest integer function. Now, if it has, the bar, the opening bracket and close bracket like this in this form, so you have to take the greatest number which is less than this given number. So the greatest number which is less than 1 by 5 is 1. Similarly, the greatest number which is less than 7.23 is 7. and the greatest number, which is less than minus 2.5, is minus 3. Please note it's not minus 2. Similarly, for 6 it will be 6, minus 4 it will be minus 4. Then the next is called the smallest integer function or ceil function. So this is an example of ceil function. This is how it's represented. So you get the smallest integer which is greater than this value given here. So 2 is greater than 1 by 5, and it's the smallest integer which is greater than 1 by 5. Similarly, for 7.23 it's 8, and so on. So that's called the ceil function and flow function, and these functions are called step functions. Next, let's move on to some other types of functions, which is one-to-one function. When I say one-to-one function, each element in X is related to only one element in Y. So A is related to X, B is related to Y. So this is called a one-to-one function. Now let's see what's an onto function. So in an onto function, you have X and you have Y, and X maps to Y. Now the key here is, in an onto function, you need to look at your range. Your range is equal to codomain, which means there is no element here in this. All the elements in Y have been mapped to or mapped from X. So such a function is called the onto function. And another name for one-to-one function is called injective function. Onto function is called surjective function. And a function f which maps from A to B is said to be a bijective if it is both one-to-one and onto function. Now these are some conditions. Let A and B be two sets with m and n elements. There is no one-to-one function from A to B if m is greater than n. If there is an one-to-one function from A to B, then m is less than or equal to n. There is no onto function from A to B if m is less than n. If there is an onto function from A to B, then m is greater than or equal to n. There is a bijunction from A to B if and only if m is equal to n. There is no bijunction from A to B if and only if m is not equal to n. Similar to the vertical test, we also have a horizontal test. So, similar to the vertical line test, we have a test called horizontal test to check whether a function is one-to-one, onto, or not. Let a function be given as a curve in a plane. If the horizontal line through a point y in the codomain meets the curve at some points, then x coordinate of all the points give pre-images for y. For example, you have here the line. This is a line, horizontal line, and this is your graph. So if the horizontal line through a point y on the codomain, so this is on the codomain, does not meet the curve. So in this case, it doesn't meet the curve at the value which is slightly less than 3. Then there will be no pre-image for y, and hence the function is not onto, which means there exist values in your codomain which is 3, and on all of these values they don't have, or they don't form an image from x. So this function is not a onto function. Second test is, if the horizontal line through at least one point of the codomain meets the curve at more than one point, then the function is not one-to-one. That's in this case, you have this horizontal line and it meets the curve at 1, 2, 3 points. So for the one value of, or 3 values of x, you have one value of y. So this is not a one-to-one function. Similarly, the last one, if for all y in the range of the horizontal line y meets the curve at only one point, then the function is a one-to-one. In this case, the line drawn here meets this curve at only one point, which is this point. That means this is a one-to-one function. Next, we'll see what is composition of functions. So let f(x) maps to y and the function g, where y maps to z, be two functions. Then the function h, x maps to z, defined as h of x is equal to g of f of x for every x belongs to x, is called the composition of f with g. It is denoted by g composition of f. Read this as f composite with g. Now, you have a function f, which is a function of f. So this gives you f of x. Now, when we input this f of x into this function g, you get g of f of x. So this is nothing but, we call this as the f composite with g. We're having a quick run-up of all the functions formulas. So let's continue. So this is an inverse of a function f. So if let f be a function from x to y, be a bijunction, the function g y to x defined by g of y is equal to x, if f of x is equal to y, is called the inverse of f and is denoted by inverse, f inverse. So inverse function is you find the inverse of the given function. Similarly, invertible, which means a function f, x maps to y, is said to be invertible if there exists a function g, y maps to x such that g composite with f is equal to I of x, identity function, and f composite with g is equal to identity function with y, where I and y are identity functions of x and y respectively. In this case, g is called the inverse of f and g is denoted by f inverse. Now, the working rule for inverse functions. Number one, y is equal to f of x. Write x in terms of y. So you need to write x in terms of y. Then you will do the f inverse. Write f inverse is equal to the expression of y. Replace y as x. So you'll be able to get the inverse function. Now, some definitions. Let x be any set. Let f and g be real valued functions defined on x. Define for all x belongs to x. F plus g of x is equal to f of x plus g of x. F minus g of x is equal to f of x minus g of x. F into g of x is equal to f of x into g of x. F by g of x is equal to f of x by g of x, where g of x is not equal to 0. Then c constant into f of x is equal to c into f of x, where c is a real constant. Similarly, minus f of x is equal to minus f of x within bracket. Now there's a theorem, which is if f and g are real valued functions, then f of g plus h is equal to f of g plus f of h. This can be proved using this method. Then polynomial of a function is defined by a function which is, so on the right hand side you have a polynomial. You see this a naught into x power n plus so on plus an. Now ai, which is a naught, a1, a2, and so on, is are constants, and such a function is called a polynomial function, and non-linear function and linear function. So let's see the definition of that. The function f defined by f of x is equal to ax plus b, where a is not equal to 0 and b are constants, is called a linear function. A function which is not linear is called a non-linear function. Then let's go to what is an exponential function. The function which is defined as f of x is equal to a power x is called an exponential function. Logarithmic function. So when you define a function using a log, then this becomes a logarithmic function. Then rational functions or ratios of two functions. Then reciprocal function, which is nothing but g of x is 1 by f of x. So such functions are called reciprocal functions. Odd function and even function. Odd function is given by the formula f of minus x is equal to minus f of x, whereas the even function, even if it's a negative value in x, you will still get a positive value of f of x. So this is called an even function. The last theorem in this introduction to functions: the product of an odd function and even function is an odd function. So this can be used using this proof. Let's move on into the exercise. Question number 1. Suppose that 120 students are studying in 4 sections of 11th standard in a school. So what we have is, there are students and you have, let me call them as A1, A2, A3 up to 120 students. Then what you have is 4 sections. So let this be section A. So let's call this as 11A. Then this is 11B. And this is 11C. And this is 11D. So you have 4 sections. Each section is a classroom, right? And you have 120 students, right? Let A denote the set of students. So this set is A, right, for the students. And let B denote the set of sections. So this is B, which denotes the sections. Now define a relation from A to B as x related to y if the student x belongs to the section y. Is this real? Is this relation a function? So let's say that, you can call this as, since it's been asked to be x, let's change this a1, a2 to be x1, x2. So we have students as x1, x2, x3 and up to x120. Then you have 4 sections, so let's call 11a as y1, y2, y3 and y4. Right. Now student, let's say this is a student x1. Okay, it can be Ram or any person. He will be in only one class. Let's say he is in the first section 11a, which means x1 is related to y, or the function f x1 is to y1. Now the same student cannot be in 2-3 classes. He will be in only one section. Let's say x2 is in section 3 and let's say x3 is in section 2. So each student can be in only one class, which means our domain function will have only one value of y. X cannot have multiple values. Therefore, this is a function. So we will put that in words, but let's just see how it is, how we can explain it using a picture. Then let us now define the 4 sections. So this is our range here. So the 4 sections, which is the sections, the classes, as, so now our x1 is changed from students to classes, x2, x3 and x4, and our students, so I'm doing the inverse of it. So let the students be y1, y2 up to y120. Now in class x1 you might have student y1, you might have student y2, maybe y3 is also in class x1. So for one value of x1, which is the domain, there will be many values in our range. Therefore, The inverse is not a function. Now let's put that in words. So let's define A is equal to set of students in 11th standard, and B is equal to set of sections in 11th standard. So the relation A to B is X related to Y, as it is mentioned here. Okay. Therefore, to answer the first part of the question, which is this relation a function? Since every student in 11th standard can be in only one section, it is a function. Second part of the question, what can you say about the inverse relation? We have seen that the inverse is not a function because each section will have many students. Question number 2. Write the values of f at -4, 1, -2, 7, 0 if f of x is given by this function. So the first, x is equal to -4. Then f of x, which is nothing but f of -4, will be equal to, when it's -4, it falls in this category where it's -x plus 4 if x is between -infinity to -3. So since it falls in this interval, so we have to use this. So this is minus of -4 plus 4, that is equal to 4 plus 4, that's equal to 8. Second, when x is equal to 1, so f of x is written as f of 1. So when it's 1, it falls in the second category, which is the interval between, it falls in the 1, 2, 3, fourth category. X is greater than or equal to 1 and less than 7. So, which is x squared, it's 1 squared minus 1. So that's 1 minus 1, and that's equal to 0. Then, when x is equal to -2, then f of x is equal to f of -2. So where does this fall? -2. So -2 is the third category, which is x squared minus x if -2 is less than or equal to x is less than 1. Therefore, using this, -2 squared minus of -2, so it's 4 plus 2, the answer is 6. Then, when x is equal to 7, f of x is equal to f of 7. That's equal to, where does 7 come? 7 is 0. Whenever it's greater than or equal to 7, which is, it falls in the otherwise category, and it's 0. So that's equal to 0. Then the last one, which is x is equal to 0. So f of x is equal to f of 0. So 0 falls in this category, which is minus 2 to 1 range. So it is 0 squared minus 0, that will be 0. Question number 3. Write the values of f at minus 3, 5, 2, minus 1, 0 if f of x is given by this function. Now note, all these are written in brackets. So we need to understand these intervals. These are open intervals here. So what does this mean? So this means it's minus infinity less than x is less than 0. 0 will not be included in the interval because it's an open interval. Similarly, this will be 3 is less than x and it's less than infinity. And similarly here 0 is less than x is less than 2 because all these are open intervals. So now let's try and solve the problem. So part A, which is x is equal to minus 3. So which is our f of x will now become f of minus 3. So minus 3, where does that fall? It falls in the first category, minus infinity to 0. So it is x squared plus x minus 5. So minus 3 squared plus of minus 3 minus 5. That's equal to 9 minus 3 minus 5, and that's equal to 1. Question number 2, which is x is equal to 5. So our f of x is now equal to f of 5. F of 5 will fall in the category of 3 to infinity. X belongs to 3 to infinity. So let's use the second formula here, which is x squared. So that's 5 squared plus 3 into 5 minus 2. So that is 25 plus 15 minus 2. That's equal to 38. Then when x is equal to 2, so x is equal to 2, between 2 to 3 you don't have any solution here, so it will come under otherwise. So you say f of x is equal to f of 2. So we take the otherwise, which is 2 squared minus 3, which is 4 minus 3, and that's equal to 1. Then if x is equal to minus 1, then our f of x is equal to f of minus 1. So minus 1 would fall in the first category, minus infinity to 0. So then it's minus 1 squared plus of minus 1 minus 5. That's 1 minus 1 minus 5. That's equal to minus 5. Then the last, when x is equal to 0. Now when x is equal to 0, it doesn't fall in any of these three intervals. You have to go to otherwise. So f of x is equal to f of 0, that's equal to 0 squared minus 3, that's minus 3.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.